So welcome my friends, welcome to the channel, and today topics will be low visibility takeoff, because I decided to upload this video due to the reason that low visibility takeoff in flight simulator is not that simple as it is in real life. Okay, so the proper sequence, or let's say when the crew come to the briefing room, they have got the flight envelope which contains many of information, and one of the information is METAR. They check the METAR conditions, and if they see that RVR it's very low, that means that there are with the highest probability within the 80s low visibility procedures in force. Basically, what does the European Safety Agency operation procedure says that all takeoffs which are below 400 meters are considered a low visibility takeoff, but you have to check always, please check your 10-9 alpha chart, and there is depicted which runway should be usable for takeoff or which shouldn't be usable for takeoff, and with some values. Within the pre-flight preparation, we always check the NOTAMs. This is partially valid for flight simulator because if, for example, here in Prague, if we are departing and there is runway 06 and 24 out of service, so we have to go to runway 12 and 30, and imagine that you have RVR of 300 meters. So in this case you are not good to go, and you have to wait for weather improvement because the minimum RVR is 800 meters, okay, for this particular runway. But imagine that runway 06 and 24 it's let's say it's fully okay, it's operable, and we can depart from runway 06 or 24, depends on the wind condition, and imagine that our RVR is 125 meters. And as you can see on the chart, for our category C, we have limitations of 150 meters. Okay, so in this case, if our operator is approved for RVR 1 to 5 meters of visibility, we can go with this value. But in real life, sometimes happens that, for example, center lines lights are inoperative, so we are using the column with high intensity runway light system. Okay, that means or let's say yeah, the center line is basically not operative, so that means that we are using the lowest RVR, it's 300 meters. So if we have 125 meters of RVR, or let's say 150, and we don't have the center line lights, we are not good to go, because our minimums it's 300 meters. So so this is in case, and it's applicable only in real life, so that's basically okay. Another problem is if your airplane is well equipped for low visibility takeoff. As you can see the picture on the top right corner, you can see bunch of informations. And for low visibility departure, the captain will be pilot flying and the first officer will be pilot monitoring. And as you can see from the picture, it is clearly depicted that, for example, a wiper on the left side should be operative, on the right side shouldn't be. Yes, because captain is pilot flying and the first officer is pilot monitoring. So this is the reason. Okay, this was explanation of the takeoff departure chart, or let's say low visibility takeoff. So once again, if we have RVR of 125 meters and our company is approved, we can go for it. That's basically no problem. If our company is not approved, we need to have RVR 150 meters. If there is some failure, for example, on RVR, or let's say, for example, runway center lights are unserviceable, we have to use RVR 300 meters. And if we have 125 meters of RVR, we are not good to go. Or let's say high intensity runway light system is not working, so we have to go to another table with medium intensity runway lights, and we have RVR 500 meters. Okay, and once again, if runway 06 or 24 is it's unusable for us because of the NOTAMs, we have to check for weather improvement, because we need RVR at least, or let's say visibility at least of 800 meters. So that's basically said that the first of all, check the meters, check the NOTAMs, if it is okay and which runway is okay for you, and if there is any restrictions on the runway, I mean in real life, but sometimes could happen that the traffic control give you another runway which is not applicable for low visibility departure, but you have to say, okay, we are not allowed to take off from this runway, may we use another runway, and so on. And the next part is the airplane should be capable of this kind of takeoff. And now we are coming to the point how to set up the airplane for the LVO. First of all, when you are during low visibility operation, and if you wait a second, I don't know why there is not number I desired. This could be okay right now. Okay, so come back. The truss setting. The truss setting always should be into the maximum truss setting without assumed temperature and with maximum full takeoff thrust. It's because if you are flying from the fog to clear conditions, in some certain point of departure you may have wind shear due to inversion or let's say isothermal layer, and in this case please do not check please do not change your configuration, so do not retract the flaps and so on. This is one point. Another point, use the less flap settings as it's possible. So for our example, we will put the flaps 1, which is enough because the runway, let's say we are going to depart from runway 06, and the runway 0624 it's quite long enough, so we are able to use the flaps 1. Again, it's because of the possible wind shear just after departure, so our takeoff speed will be 132. And now the now setting. The now setting should be always for approach setting if we have the availability that our departure runway, which is LVO approved, has the ILS as well. We have to tune it because it has some advantages and some procedures. So we put courses of 061 like this one, 061, and on ILS DME we put 111.15. Okay, and the captain should have normal map mode on navigation display, and first officer should have the approach mode. Why approach mode? Because he will constantly monitoring 80 knots, V1, rotate, engine instrument due to rejected takeoff, and so on and so on. And in this case, he should tell you to deviate if you are deviating from the center line to the left or to the right. So this is the navigation setting for our particular departure. I will as well set the runway heading for departure, because it is crucial to have it there, and with initial climb clearance 5,000 feet. Okay, so that's it. Another point I would like to say, it's adjust your brightness of your instruments. So for example, start with FMC and brighten it a little bit, because otherwise you don't want to be blinded by your own instruments. Okay, so let's say inboard view, we can brighten it a little bit down. Outboard view, we can brighten it a little bit down. Standby instrument as well, and upper view, we brighten it a little bit down, and the same situation should have the first officer. What we need to have it a little bit floodlights, okay, on one and on the second side. Prior to taxi, you should follow the green taxi lights. These taxi lights are assigned especially for low visibility, but there is an exception of ICAO, as you can see on the top of right corner. In some part of the, or it's some kind of the airport, you shouldn't have green lights because there is sufficient visibility, like in apron, or you have, for example, high intensity edge taxi lights, which are let's say clear enough for low visibility taxiing, but I am not comfortable with this because it's not true. If you have serious visibility of 125 meters, you are happy to see the green lights, not even to see the edge lights on the runway. So this will be the taxi routing. Remember, as you are flying in low visibility, even if the summer days the temperature could drop, so you have to consider using engine anti-ice. Now, as you can see, we have 8 degrees of centigrade, And engine and criteria says to us that if the visibility is less than 1 statute mile, that means less than 1600 meters, we should use the engine anti-ice. So I will start the engine anti-ice. Regarding to your let's say light setting, it is completely up to you which light settings are you preferred. Okay, because I will put it like this. Okay, and now if you feel comfortable with this situation, that's pretty fine, that's okay. If you are not comfortable with this situation, okay, you may use the external taxi light to your liking, for example, like this one, okay, if it is more better for you. But in real life, and it's really in real life, it means that imagine that you are driving the car in the fog and switch on the lights in front of you, and basically in real life you can see the nothing. But as we are on the flight simulator, you can adjust the lights into your liking, but in real life the most pilots are leaving these lights turning to off position. Okay, one important thing is as we are departing, we should have filled in our operational flight plan and ICAO flight plan, which is going throughout the European Eurocontrol validation, and we should have filled the takeoff alternate. Why? Because if we have suddenly engine failure, we are not able to perform the low visibility with one engine failure, because most of the NGs has failed passive system, and that's what we are talking about. So in this case you are not able to reland, and you have to establish your takeoff alternate, and then some conditions to be fulfilled. The first, the takeoff alternate should be 60 minutes with one engine in operative flying in still air conditions, and the weather conditions should be 1 hour prior to your arrival time and 1 hour after, about category 1 minima, or if the airport has, let's say, NDB or VOR approach, about these minimums. So this is the procedure, and roughly says on Boeing 737 your takeoff alternate should be approximately it's a rough computation of Boeing pilots, it's approximately 260 nautical miles ring. Okay, so in our case I will advise to the tower, if it is not filled in OFP, that our takeoff alternate will be Brno in order to be prepared. And if the air traffic control knows that the Brno is closed, so we have to pick up another airport. Okay, so we can take, for example, Pardubice airport, okay, or Ostrava, whether it doesn't matter. Okay, so I think that was clear enough, and now we are good to go. We've got the taxi clearance, then we have to taxi via Hotel Foxtrot and all the way down to runway news. Okay, so I will just prepare my joystick, and now we are ready to taxi. So we will release the parking brakes. As the brakes are released, we adjust smoothly the power and the taxi with low visibility very slowly. Okay, so left side is clear, right side should be clear, that's okay. And now if we don't have the taxi guidance light from the stand, from the appropriate stand, now we are basically going straight ahead, and first officer is always watching the charts, communicating and navigate the captain with the taxi routing. So now as you can see, we stop because we don't know where we are, for example. Okay, so we hold position and we check it with the map, and what does the map says to us? That we are approaching taxiway hotel. Okay, so this is hotel, and then we join the Foxtrot. That's okay. So first to the right, so we will join the right taxiway, and now the situation becomes a little bit tricky because now we are, let's say, at the point that the taxiways are splitting. So if we are in doubt, we stop the airplane. Do not forget to put the parking brakes, and remember, once you stop the airplane, you must notify ATC that you stopped the airplane because of some reason. For our case, we will ask the ATC, and do not hesitate to ask the ATC, that we've got lost and we don't know which one is taxiway Foxtrot. And air traffic controller should tell you, okay, the taxiway Foxtrot is not first to the right, but second to the right following. So now we are aware where is the taxiway Foxtrot. We can release the brakes, and we can continue with our taxi. Okay. And I forget to mention about the limitations. Be aware of the fact that in most of the companies the standard limitation for low visibility operation is not valid due to wind conditions, and you have reduced wind limitations. Okay, so be aware of the fact. And now, for example, I don't see on this side we are approaching the runway. We are on Foxtrot, so we are okay, and we are approaching runway 3012. So we put the strobe lights in order to see if there is some traffic, even if the runway is it's not in use. Okay. And regarding to the fuel, if you are performing low visibility departure, that means that in real life you are not allowed to taxi out from the intersection, because we need to use all of the full length of the runway. So intersection it's not available for us. So I will put it like this one, and now we can make a before takeoff procedure, checklist, flaps, trim settings. We have we are ready to go. Okay. So intersection delta, we have to skip it. However, our situation that we put the full thrust without the assumed temperature and everything leads us to unbalanced takeoff. That means that our accelerated stop distance available will be much more than our takeoff distance, which we have actual. So but this is the purpose. This is the purpose. And remember another thing regarding to the rejected takeoff. In case of rejected takeoff, you should be aware from ATPL theory that last 900 meters are continuous lights, which is white and red, and last 300 meters it's continuous red lights. It's because in order to know that the departure end of the runway are really close enough, and if we are on high speed we have to do something with it. Okay, so this is regarding to the rejected takeoff procedure in case of something happens. Some companies are using APU for low visibility departure in case they have some troubles. For example, they lose the generator or everything, so basically we can start the APU and we can make this procedure as well. And as I said before, again, use of the lights, it's just to your liking and nothing special. What I recommended from real life, do not use any lights because you see nothing basically. And regarding to the takeoff, you may deviate from the standard procedure and you may leave it into the steady no strobe, because the strobe lights in fog are really blinding you and make the situation much more tricky for departure, which is not good. And the captain has the responsibility of the airplane, and captain may, according to the regulations, may deviate from the procedure in case of flight safety. So now we are approaching cut 2 and 3 holding point. What does it mean? It does mean that if the runway 06 it's low visibility, it's low visibility approved, so it should happen that the airplane is coming and we are not going to disturb this signal, this glide slope signal, so we have to wait in cut 2-3 holding point, which is sorry for that, which is right this one. Okay, and what we are going to do, if we have the lights on, we switch off the lights. Okay, it's because do not shine the other airplane, because he need to see the 3 elements of the runway in order to perform the landing. And what is important, leave your transponder into the S mode or squawk mode Charlie. Do not put it into the TARA. If there is any malfunction, it can lead to conflicted traffic and go around. But this is in deep when some failure could happen. Okay, so anyway, we are let's say ready for lineup. I don't see the lights. Okay, these are the taxi lights. Fine, and now we can put the transponder to TA mode. Okay, and as I said before, I switch the position lights to off. However, we don't have the strobe effect here right now, but in real life it's really annoying and it's blinding you. Always when we are lining up the low visibility runway in use, so we have to check, it is runway 06, yes, it's a runway 06, so that's quite perfect. But follow these green lights. Why? I will show you why within a while, because now, as you can see, we have white line, and we can easily make a confusion and let's say we think that this is the runway center line marking, and we align with within the improper way. So in order to avoid this situation, always follow green lights until you are on the runway, and once you are on the runway, you stop the airplane when aligned and just confirm the heading is matches your runway conditions, and first officer just confirm that there is no deviation from the center line. And now we are good to go. And remember, after departure, once we are out of the clouds or out of the fog, we can encounter the wind, we can account for the wind shear. So if there is wind shear presented or strong turbulence, do not change the configuration until you leave these conditions. So the takeoff is pretty standard as it is usually. So 40% we've got it stabilized, we put N1 toga, and now we are performing the departure, the takeoff roll. Okay. So we have 80 knots checked. V1 rotate. Positive rating, gear up. Okay, and now follow the flight directors. At 400 feet, put the L now, and if you feel busy, put the autopilot engaged. Okay, and now we are good to go. And as you can see, the temperature is 10 degrees of centigrade, but it could rise. So always watch the temperature, and according to the situation, adjust the your engine anti-ice. So assume that we have, for example, flight level 100 climbing. Flight level 100 is set. We have acceleration altitude. So put flaps up speed, and as you can see, we have no wind shear, no strong turbulence. So we may change the configuration and start to accelerate the airplane into the en route climb speed. 250 below flight level 100. So yeah, we are approaching flaps 1 speed, so we put flaps up, and as soon as we have flaps up, I can make it like this one. Just to see if we have flaps up, no light, we can put V now. Everything, it goes back. Temperature is 3 degrees, but we are out of the clouds, so we can switch off as well the anti-ice and start switches back to off position, and we may switch off the APU, okay, in this case. And that's it. That was the low visibility departure, quite in details. So I hope you like this video, and see you next time soon. Bye bye.